Hello, thanks for checking out this video where I'm actually going to make a key light. So the key light's the light that's actually illuminating my face now. In the previous video, I made those gradient background lights that you can see behind me. But today we're going to make the one that you can't see because it's illuminating me. Again, it's going to be controlled by a mobile phone using the WLED application. And if I just give you a quick demo, I can change the brightness to bright, right down to a silhouette, and I can change the color temperature from warm white, really yellow, to really cold white. So I just leave it somewhere in between. So we're going to make this using an ESP32. So it's a little microcontroller board, costs say a few dollars from AliExpress, and just a couple of MOSFETs and an LED strip that has warm white LEDs and cold white LEDs combined in a single strip. So let's get started. Well, the circuit for this lamp is really quite straightforward, but it needs a little bit of explanation first, because I didn't really find any details online to actually explain how to wire this particular LED strip up. So the LED strip I have, which I'll show you, give you more details later, basically has three terminals. It's got one labeled plus 24. That's where we put our 24 volt input. It's got one labeled CW and one labeled WW. CW stands for cold white, WW stands for warm white. And actually, if you look at the top right-hand side of the screen now, you can see how it's wired up. So there's a sort of schematic of the LED strip, and we've got the 24 volts on one side of the LED and either WW or CW on the other side of the LED. So if we connect our drain of our MOSFET to the LED strip, the WW or the CW, when we turn the MOSFET on, current will basically flow from the positive to the negative and through the LEDs, making them light up. So that's how the LED strip's actually configured, and that's not really clear from any resources I saw online. So now let's think about how the circuit actually works, the control part of it. Well, to actually make this light work how we want it to do and be compatible with WLED, we're going to use this ESP32. Two outputs from that are going to connect to the gates of these two MOSFETs pictured at the sort of top of the screen. Those MOSFETs are connected one side to the LED strip and the other side to ground. So when they're energized or activated by the ESP32, they're going to switch on and current will flow through the LEDs. Obviously, there's two of them because there's the warm lights and there's the cool white lights. So we need two switches that we can switch independently. The rest of the circuit is also straightforward. We have a 24 volt DC power supply. Obviously, that's taken to power the LED strip, but it also goes into a voltage regulator, which reduces the voltage down to 5 volts to actually power the ESP32. And that's really it. The circuit's super simple. Just be careful that the outputs or the pin assignment on your ESP32 might be different from what mine is. So you really need to check what's printed on the actual board to find out where the V in is, the ground, and what the pin numbers actually are. So let's go and actually look at how we make this in the lab. So these are the particular LEDs I bought. It's a 5 meter strip, 24 volts. There's the warm white and the cool light. So we'll take a closer look in detail about these. I guess different brands have different parameters, but these were not particularly cheap, but they do have a high color rendering index, which means that the quality of the light is really good for making videos and things like that. So probably worth spending a little bit more. And here's the actual LED strip. You can see there's quite a lot of them. And if you look closely, you can actually see they're printed with the particular sort of assignments of what each pad is. So you can see the plus 24 volts. You can see the CW and the warm white as well. You don't have to use those wires for connecting to the strip. You can actually solder to any of the copper pads and it'll work. And you can cut the strip at any of the copper pads as well. So that's also really helpful, as you'll see later in the video. So to build this lamp, we're going to need some kind of physical reflector to house that LED strip in. And I've chosen this stainless steel PET bowl. I thought I was playing an absolute blinder here because there's several example videos on YouTube where people have used like cake tins to build the light. Whereas I thought I'll buy this PET bowl because it's much cheaper. But what I didn't realize, it's got sloping sides, and that's caused a major problem when I come to stick the LED strip around the circumference. I've also showing here the LED driver that I purchased. Again, I got this from Amazon, and it's a 24 volts DC source. So it basically takes in AC mains voltage and gives out 24 volts at 2.5 amps. I initially thought I'd actually mount that with inside the lamp. There's so little space that I'm a little bit hesitant. So in the end, I actually opt not to put it inside. I actually mount it on the outside of the lights in a plastic box, so it's insulated. So very shortly now, you'll see that I've made a massive mistake in buying this particular bowl. Because of those sloping sides, it's almost impossible to get the LED strip to fit around the circumference. I just couldn't do it. And when I say I spent at least 2 hours messing around trying to get that strip to stick to that bowl, I'm not exaggerating. It was unbelievably frustrating. I tried every different, starting from the bottom, working up, starting from the top, working down. It just would not work. Ultimately, I gave up on that idea, and I thought I'd actually cut the strip and basically insert strips into the lamp housing. This worked, which is good, but it added a massive amount of time rather than just using the whole strip. Because everywhere I cut the strip in sort of 10-inch segments, I had to add 3 wires to connect it to the next segment of, 10 inches. So I ended up with sort of, 10 plus strips, all that had to be connected together with wires at the end, and it became very confusing and very messy. So I'll fast forward showing you that process. It took several hours. Obviously, if you buy a better bowl that doesn't have sloped sides and you can actually just stick the LED strip around the circumference, you won't have to do any of this, and it'll be so much quicker and so much easier. You could probably build this light in sort of 30 minutes rather than 5 hours.
A few moments later.
So having stuck most of the strips, not quite all, but most of them, I'm thinking about how I can actually mount the power supply on the lamp and that it's going to be safe. So I found this like plastic Tupperware box, and I plan to mount it on the back of the lamp where there's a gap in the LED strips. As you can see, the power supply itself is really simple. There's just an input and an output. The input, I believe, is somewhere between 100 and 240 volts, so it can do both US and sort of Europe, UK input voltages, and the output's just 24 volts DC. So I'm going to put the mains wire in through a cable gland, and out of this box will be the 2 basically drains of the MOSFETs, which are going to go to the LED strip, and the 24 volts. So there's going to be 3 wires going through the metal housing and into the actual lamp. So slightly different to what I said at the start, I'm actually not using a linear voltage regulator like I showed in that circuit diagram, basically because I didn't have one. I have this switch mode little power supply that takes a mains input and gives a 5-volt output. So this is just a replacement of the regulator I showed on the schematic, and it actually adds complication and danger to the circuit. So do as I say and not as I do here. Don't use one of these expensive little modules. Use a perfectly adequate little 5-volt regulator to give the 5 volts needed for the ESP. You just plug the 24-volt input into its input side and take the 5 volts for its output side. So now I'm really thinking about how to exactly mount this little power supply unit on the back of the lamp. So it's just making sure I don't drill through any of the strips. That should be easy. But actually, because it's stainless steel, the ball was really a pain to sort of drill through. Managed it in the end, but I'm pretty sure it blunted my drill bits quite significantly. Now I'm looking where we can actually mount the heatsink for the MOSFETs. So although the MOSFETs don't get hot, they do really need heat sinking because they just don't have any heat dissipation capacity at all with that tiny little metal tab. So they need mounting on a heat sink, but they can't just be directly connected to the metal because the metal tab is actually the drain of each MOSFET. So we need a little insulating pad that sits between the MOSFET and the heat sink. So I'm adding those now, and I'm trying to figure out exactly where this is going to go in the box. As you'll see, it's quite, a tight squeeze in there. But that's really it in the end. Everything does fit and there is enough space. One additional component that I didn't actually mention before is this little tripod ball joint mount thing. I basically bought this so I can actually mount the lamp on a tripod or a clamp stand or something like that. It really just makes it convenient for filming videos if you can have this light on a stand. Again, it was just an Amazon purchase that cost a few pounds, and it's really useful. So I recommend you get one of those as well. Of course, it's not essential. It's easy enough to mount that light on a chair, for example, or anything if you're really on a budget. My final task is really just to wire this power supply up. It's not complicated. It's not many wires. Space is a little bit tight, which complicates matters somewhat, but it's still no problem. And I'm just wiring using sort of stranded wire directly to the pins of the MOSFETs and using the screw terminals on the AC power source. So that's straightforward. What I haven't done yet is connect all the lights strips together inside the lamp. That's coming next. But this bit only takes 5 minutes. And this bit's really what you'll need to repeat if you're going to make this lamp. Before connecting all the LED strips together, I decided to add a few additional strips just to fill the gaps at the sides and between the sort of screws that hold the power supply on the back of the lamp. So now that's done, I start doing the very time-consuming and horrible job of connecting all those strips together. And believe me when I say it was a real pain because it's not a flat surface, so I kept having to tilt the lamp, trying to get them on. I kept shorting out between the two warm whites and cool white pads. Almost every time I connected a new strip, I basically went to my benchtop DC power supply to check if it worked and make sure it wasn't shorted out. So you can see how many strips there were, and you can imagine how long that process took. Of course, none of this would be needed if the strip was complete and it hadn't been cut. So don't get the slope sides. If I can give you one piece of advice, get a bowl or a cake tin with straight flat sides so you can just stick tape on. So once that's done and all the lamps are connected, it's basically finished. But the one thing you haven't seen me solder so far was the ESP32 because I actually forgot to take it to the lab that day. So here I am at home. I've got my ESP32 and I'm actually going to mount it directly on top of the 24 volts DC power supply. So I'm just going to use double-sided tape. And if you think about it, there's actually only 4 wires that need connecting to the ESP32, the 5 volts, the ground, and the 2 outputs that go to the MOSFET gates. So once that's done, it's ready to configure the software, which can be done wirelessly. Here I am back in my kitchen, and I'm configuring WLED remotely using my Wi-Fi to connect to the ESP32. You can also see on the lamp that I've actually added sort of a diffuser cloth. So this is something, again, I bought from Amazon. Does a great job of diffusing the lights so you don't see the individual LED strips. So I'm just setting up WLED to get the right output pins, and I've put it on PWM mode. So now you can see I've switched the lamp on. It's beautifully uniform illumination, and I can also change the color temperature and from very yellow right through to very white. And I can also change the brightness from basically off to quite intense. And here I'm actually limiting the current so it's not so bright, but it can be a lot brighter. So really that's it now. We can actually connect it to the tripod and use it as a key light to make some really nice videos. So just to summarize this video, we used two MOSFETs to pulse modulate cool white and warm white LEDs so we can actually adjust the color temperature. We used an ESP32 and the WLED application to actually control that process so we can dim and adjust the lights however we want. That's pretty cool, but I'm a little bit unhappy with the light. Although it looks pretty good, I think we can do more. This is the circuit helper, and although we are building circuits in this video, they're not actual electrical engineering is what I'd say. So in the next video, I'm going to actually make a constant current source to be able to vary the intensity of the cool white and the warm white LEDs. That should actually give better light quality if you think about it, because at the moment, this light's been switched on and off very quickly, so quick it appears continuous. But if you use a constant current source to vary that intensity, then you'll actually won't be switching the light on and off, you'll just be gradually varying its intensity. And that, in theory, should give a better light quality. So with that, thanks for watching. Hope you found the video useful and enjoyable. If you did, like and subscribe. And of course, if you've got any questions, put them in the chat. See you in the next video.